All right, objective 5, we're working with applied problems, which basically means word problems. Okay. All right, example number 1, let's just kind of consider this a warm-up because we're not going to see as many problems like this year with a bunch of letters, but we are going to solve equations that look like this. So let's dive right into example number 1. If we want to solve example number 1, which I'm going to rewrite, we got 1 over a equals 1 over c plus 1 over d. Okay, so then there's our equation. I got it spread out on purpose. And then if we want to solve for a, well, how do we solve for a? Well, the first thing we need to do is get a out of the denominator. I don't want to solve for 1 over a. It's already got 1 over a by itself. I want to get just a by itself. So then I want to multiply everything by a to get a out of the denominator. I also don't like having these fractions, so let's get rid of all the fractions, and we want to multiply everything by an a and a c and a d. So I want to multiply everything by ACD. And I'm deciding to use capital D's, I guess. All right, on the first fraction, the a's are going to reduce, and I'm left with 1 times cd, so we get cd. I'm going to go back to lowercase, I guess. Here, the c's are going to reduce, and I get 1 times ad, which is ad. And then here, the d's are going to reduce, and we get 1 times ac, which is positive ac. Okay, so good, we got a out of the denominator, and we got rid of our fractions. Great, then what's the next step? Okay, our next step, we don't like having a in 2 spots in our equation. Now, this is probably the trickiest part for you guys. How do we get just 1 a in there? Okay, well, one thing we can do is factor out the a, because these 2 terms have a common factor of a. So I want to take out a GCF from that binomial right there. Okay, so CD stays the same. And if I take out the a, then I'm left with just d plus c. Okay, and then now I have a times this thing. Well, I want a by itself, so then the opposite of multiplying by d plus c, divide both sides by d plus c. And then these are going to reduce, and I get a by itself equals cd over d plus c. And then that's my answer. Okay. Now the word problems are going to have more numbers and not as many letters, so there won't be funky answers like this. But anyways, that is example number 1. All right. So the key on that one, fill in the blank up here, was to clear the denominator by multiplying by ACD. All right, now on to the actual word problems. Okay, so the word problems, typically we're going to see 2 different types of word problems. One of those types is work problems. So work problems will be one of 2 categories. The individual plus the individual equals job complete. So in other words, if 2 people are working together to complete a job, how long might it take? Or if we know how long it takes them to work together, minus I know how long it takes one of them to work, that'll tell us how long it takes the other person to work. Okay, now it's not quite that simple. We got to work with fractions and stuff, but let's see what those are going to look like. We'll dive right into example number 2. So example 2 says the Pardinis are having an outdoor barbecue next weekend. Their sons are Tony and Frank. If Tony works alone this weekend, it'll take him 8 hours to clean up the backyard. If Frank works alone, it'll take him 10 hours. How many hours will it take if they work together? Okay, so then this is one of the first type of problems here. We want to see how long it takes Frank and Tony to get the job done. Okay, so when we're setting up our equation, it's not just individual, so it's not just Frank plus Tony. It's how quickly they work. Okay, so how quickly does Frank work? Let's see. I'm sorry, Tony first is the one they listed first. How quickly does Tony work? Well, Tony can do the job alone in 8 hours. So then how are we going to write that? Okay, well, we're going to write it like this. We're going to put T for time, not for Tony, but T over 8. Because think of it this way. If he works for 8 hours, well, 8 over 8, he can get 1 job done. If he works for 4 hours, well, 4 over 8, that's 1/2. He gets half a job done in 4 hours. Okay, so this is Tony's work rate. Okay, so that's how quickly he works. Plus, he's not working by himself. He's also working with Frank. And then how quickly does Frank work? What is Frank's work rate? Okay, well, Frank can get the job done in 10 hours. So then it's time he works over 10. Okay, because again, if Frank works for 10 hours, then he can get 1 job done. If he works for 5 hours, that'd be 1/2. He gets half a job done. So this is how quickly Frank works. Okay. And then equals, well, how many jobs are they trying to complete? Well, just one. They want to get that backyard cleaned up. Okay, so then here's our equation, and that's the hard part of setting it up. And now the easier part is solving. Okay, because we've been working with these types of equations, so this shouldn't be too bad for us. All right, now we don't like having fractions here, so then what's our first step going to be? What can I multiply everything by to get rid of these two numbers? Now that times that will always work, but is there a smaller number than 80 that both of these go into? And yeah, 40 will work. So I can multiply everything in my equation, including the 1, got to do all parts, by 40. Okay, and when we do that, this is going to reduce. 40 divided by 8 is 5, so we get 5t. Plus 40 divided by 10 is 4, so plus 4t equals 40. Now, real quick, before I finish this problem, also, how long should the job take about? Let's talk about that. We can estimate how long it should be about. So think of it this way: Tony can get the job done in 8 hours. Well, what if there were 2 Tonys? Well, then he can do it in half that time, so that'd be 4 hours. Okay, and then Frank gets the job done by himself in 10 hours. Well, what if there were 2 Franks? Well, then it'd be half the time, it'd be 5 hours. So 2 Tonys can do it in 8 hours, 2 Franks can do it in 5 hours. What if there's 1 of each? Well, is it going to be right in the middle? Well, not right in the middle, because since Tony works faster, he's going to get a little bit more than half of the job done, right? If they're working until it's done, he's going to maybe do 52% of the job, and his brother does 48% of the job. So it'll be a little bit less than in between their time. Okay, so again, 2 Tonys gets it done in 4 hours, 2 Franks gets it done in 5 hours. So we're thinking right about 4.5 hours, but really a little bit less than 4.5 hours. So we're expecting our answer to be a little bit under 4.5. Okay, and then let's see what we get. Now that we've got no more fractions, here we can combine like terms. I get 9t equals 40. And if we divide both sides by 9, then we get t equals 40 over 9. And if we write that as a mixed number, 9 goes into 40 how many times? We get 4 times, with the remainder of 4 9ths left over. Which, yeah, that's a little less than 4.5. Okay, because 4 and 4/8 would be 4.5. So 4 and 4/9, that's a little bit less than 4.5. So just like we expected, it's this many hours. Okay, so again, a little bit under 4.5 hours. Okay, and that's our answer. If you want to type in 40 over 9 on a calculator, you'll get a decimal, but again, that's our answer right there. Okay, so again, it's the work rate of the first person plus the work rate of the second person, and in this case, it's done in hours, equals how many jobs we're trying to complete. Okay, and then hopefully the solving isn't hard once you have the equation. All right, next example, number 3. It says, at the Baxterville City Fire Training Facility, a training structure is set on fire. If 2 crews work together, they can put out the fire in 50 minutes. Alone, the less experienced crew can put out the fire in 110 minutes. How long will it take the more experienced crew to put out the fire if they were to work alone? Okay. Also, I'm sorry, I want to come back up here real quick. Just want to add a little something for your notes. How did we set up our equation? Well, basically it was Tony's work rate plus Frank's work rate equals 1 job done. Okay, and then when we solved, the key was to multiply everything by 40. Multiply all terms by 40. Okay. All right, now back to our problem that we just read here. We want to see how long it takes the more experienced crew to put out the fire if they were working alone. Okay, so one of the keys that we want to keep in mind here for this one, put it up here, we'll have plenty of space. This time we're not working by the hour. This time it's how many minutes they can put out the fire in. So we're going to write rate is how fast they work per minute. So the rate is how fast they work per minute. Rate is how fast they work Okay. All right, and then this time, it's the second type of work problem, where it's, I know how long it takes them to do it together, and then I want to subtract how long it takes one of the groups to do it, and that's going to give me the time for how long it takes the other group to do it. So it's going to be like that problem. All right, so then how do we set this one up? Well, how long does it take the, both crews to do it together? It takes them 50 minutes. Okay, well then how much of the fire can they put out in 1 minute? Well, 1/50th of the fire. So we're going to put 1/50. That's how fast they work together. That's how much of the fire they can put out in 1 minute, in other words. Okay, and then minus the less experienced crew can do it by themselves in 110 minutes. So then how much of the fire can they put out in 1 minute? Well, 1/110th of the fire by themselves in 1 minute. So again, this is how fast they work together per minute, and then how fast one of the crews works together per minute. Okay, and then if we take how fast they work together minus how fast the one group works, we should get the work rate for how fast the other group works. Okay, and then how fast does the other group work? Well, they can get well, that's what I'm trying to figure out. How much of the fire can they get done in 1 minute? Okay, so 1/x is the other part there. Okay, hopefully that made sense. Now we've got our equation set up, and now we can solve. Okay, and then to solve this, well, what do I want to multiply by to get rid of all of my fractions? Okay, well, we can multiply by 550x. That would be the LCM between these three things here. Okay, and when we do that, and you can write it 550x here, 550x here, 550x here, or you can write it one time and just distribute. You know, it's up to you. And then when we distribute and reduce, we would get 11x minus 5x equals 550. Okay, because here the x's will cancel, just to be left with 550. Anyways, that's our new equation. Okay, so that's looking a lot better than our original equation. Just a couple numbers here and no more fractions. All right, let's start by combining like terms. 11x minus 5x, we get 6x equals 550. And then divide by 6. And we get x equals 550 over 6, which when we reduce that, we get about 91 2/3. Okay? In other words, that's going to be 91 minutes. And then 2/3 of a minute would be 40 seconds. So 91 minutes and 40 seconds. All right, so the less experienced crew can do it in 110 minutes. The more experienced crew can do it in 91 minutes and 40 seconds. Okay, so again, the key here is that the work rate is in minutes this time. How much of the job can they do together in a minute? How much of the job can one crew do by themselves in a minute? And that's going to give us the work rate of the other crew. All right, so there's number 3. Let's move right on to the next page. And then 2 more to go. All right, so no more work rate problems. On the back page here, we're dealing with average cost problems. All right, like it says, in these problems, we'll start out with an average cost, but then something will happen. If more items/people are added, then the average cost decreases. If items/people are removed, then the average cost rises for those remaining. Okay, that'll make more sense when we look at the actual problems. Let's look at the first one here, example 4. All right, a small group of students are having a study session one night. They realize that it's going to be a long night and they order pizza. The order amounts to $24. Before the pizza arrives, another student joins the study group. With the additional person, the average cost of the pizza decreases by $2. How many students were originally in the study group? Okay, so let's think that. Does that really make sense? Well, sure, because we order some pizza, it's going to cost $24. The pizza's already on its way, we're not changing our order. But if one more person joins the group, well then, yeah, we all get to pitch in a little bit less because there's one more person helping pay for it, but the same amount of pizza is coming. In other words, the cost didn't change for the total, but everyone's portion will change a little bit. All right, so how do we set up our equation here? Okay, so normally it's going to be something like this: the average cost of the original group, and then plus or minus the adjustment, how much did the price change for each person, and then that's going to be the average cost of the new group. Okay. In other words, it's the original cost and then plus or minus however it changed. And then how did it change in this case? Well, said the average cost of the pizza for everyone decreased by $2. So it's going to be minus $2 in this case. And then that's going to equal the new price per person. So the original cost per person minus $2 is going to give us our new price. Okay, well, what was the cost originally? Okay, well, the total cost of the pizza was $24. Well, was everybody paying $24? Well, no, that's split up between how many people? Well, that's what we're trying to figure out, how many people were in the group. Okay, so then the original cost per person is $24 divided by how many people there were. And then what happened to that price? Well, it went down by $2. Okay, and if I take my original price minus $2, then I'm going to get my new cost. So what's the new cost going to be? Well, the total is still $24, and now we're dividing it by how many people? Well, we had X number of people, and then one more person joined the group, so then X plus 1. Okay, so then this is our equation for this problem. All right, and then now that we got the equation, now we can start solving. I want to get rid of my two denominators, so I got to multiply by X to get rid of that. I got to multiply by X plus 1 to get rid of that. So then I want to multiply everything, and I'm going to write on each term by X times X plus 1. The negative 2 times X plus 1, X times X plus 1. Okay, and then when we do that, what are we going to be left with? Well, here the x's are going to reduce, and I get 24 times X plus 1, which is 24X plus 24. And then minus, I've got negative 2 times X, which is negative 2X, times X plus 1, which is negative 2X squared, minus 2X. Okay, so don't forget we're distributing a negative 2 there. Okay. Next, equals, sorry, I was looking at something else. The X plus 1s are going to cancel over here, and we get 24 times X, it's just 24X. Okay, so there is our problem. All right, let's start to simplify this a little bit. Well, the first thing we can do, since I have 24X on both sides of the equation, let's subtract 24X on both sides. And then that disappears completely on both sides, so that's nice. Now we're just left with this stuff here. So we get 2X squared, sorry, negative 2X squared, minus 2X plus 24 equals, now we just have 0 over here. Okay, so now I've got a quadratic. How do we solve that quadratic? We can try to factor, we can use the quadratic formula, but especially if we're going to factor, why don't I like to factor this problem? Well, it's got a leading coefficient in front of my squared term, and it's negative. Okay, well, let's fix that. What can I do to an equation? Well, pretty much anything I want. So let's divide everything in here by negative 2, including the 0, but it won't change it, so that's fine. We'll take this up here where we have a little more space. And when we divide everything by negative 2, we get positive X squared plus X minus 12 equals 0. Okay, now this is going to be easier to solve. We can factor this thing. I know my signs are different, so I got one positive and one negative. I got to have X and X to get X squared. And what multiplies to 12 has a difference of 1, 4, and 3. The bigger one is positive. So X plus 4 and X minus 3, which gives me answers of negative 4, I'm writing them separately, and positive 3. Okay, so then are these my two answers? Well, no, they're asking us how big was the group. I can't have two different sizes. Okay, so which answer works? Well, can I have negative 4 people in my study group? No, that doesn't make sense. So even though we got two answers, only one of them makes sense. So the original answer is 3. Okay, now, the other nice thing about these problems, it's super easy to check. Okay, does that make sense? Let's see, if the pizza costs $24 and there's 3 of us, how much are we each paying? Okay, $8. What if one more person comes? Now the pizza costs $24. What if there's 4 of us? Well, now we're each paying $6. So yeah, my cost decreased by $2. So it works. Okay. So anyways, on these problems, you're often going to get two answers, but only one of them should make any sense. Okay? All right, last one here. All right, this one's a little bit different. Example 5 says an amusement park gives group discounts. Last month, a certain size youth group paid a total of $651, and again, we're looking for the size of the group. They paid $651 for admission tickets. This month, they were told that if 4 more people join their group, they would pay $990, resulting in a $3 discount per ticket when compared to the prior visit. How many people were in the group that visited the park last month? Okay, so this is going to be a lot like the last problem in the way that we set it up. We're going to look at, well, what was our old price, our original price we paid, and then how did the price change when more people joined the group? It's a $3 discount per ticket. So our old price went down, so we're going to subtract by $3. Okay, we can even put a dollar sign if we want to. Old price went down by $3, and that's going to equal our new price. Okay. All right, so then what was the old price? Well, we paid a total of $651, but did we each pay $651? No, that was divided by how many people? Well, that's what we're trying to find out, so then that's what our X is. Okay, and then this price for everybody went down by $3. Okay, and then that's going to equal our new price, and what's our new price? Our new price, we paid a total of $990 this time. And then how many people was that split in between? Well, the original group plus how many more people joined the group? 4 more people, so X plus 4. Okay, all right, so now we've got our equation, and now we can solve this thing. All right, so then what do we want to multiply by to get rid of both of these denominators? Well, we got to multiply by both of those denominators. So we got to multiply by X and X plus 4. So I want to multiply everything by X times X plus 4. All right, over here the x's are going to reduce, and I get 651 times x plus 4. So we're going to get some big numbers here. A calculator would be helpful. That's going to be 651x plus 2,604. 2604. And then we got negative 3 times x, which is negative 3x, times x plus 4 is negative 3x squared. Minus 12x. Okay, and then equals, over here the x plus 4 is reduced, and I just get 990 times x, which is 990x. All right, so we've got our problem set up. The first thing we want to do, since it's a quadratic, is set it equal to 0. So I want to start off by subtracting 990x from both sides. Okay, and then that's going to give me, let's write this in descending order. So I'm going to do my x squared term first. So that's going to give us negative 3x squared. And then we got these x terms minus 12x, and we combine like terms, we're going to get negative 351x. And then this is my only number, so plus 2,604 equals 0. Okay, so we got some big numbers. Good news is they're all divisible by 3. So let's divide everything by negative 3, including the 0, even though it won't change. And that'll make our problem a little bit more manageable. Okay, so here we're going to get x squared plus, when we divide that, we get 117x minus 868. Equals 0. And then next, we can use the quadratic formula, or we can factor this thing. I know it's hard with the big numbers, so let me just factor that for you. Do it right here below, I guess. Okay, so just trust me on this one. It's going to be x plus 124 and x minus 7. Okay, which gives us answers of x equals negative 124 and x equals positive 7. All right, so those are our two answers, but which one makes sense? Well, can we have negative 124 people in our group? No, so our answer is 7. And again, if you want to check, plug in 7, see if it works with those numbers, yeah, it will work. So, 7 people is our answer. Okay. All right, so if you have questions, of course, let me know. The hard part about these is setting up the equations, but hopefully these notes made some sense.